Hello and welcome everyone to the fourth session of our Devon and Beyond Security series. If you missed any of the previous sessions, you can find the recordings on the same Devon and Beyond page. And while you are there, please take a moment to review the other series and webinars that we have added for you. For those who are new, Devon and Beyond webinars are hosted on Cloud Customer Connect, which is our Oracle community forum for end users. If you have not already, I invite you to create a free account on Cloud Customer Connect, join in discussions, ask questions, and look for upcoming events on various topics. In today's session, you'll be introduced to Oracle Cloud Network Firewall Solution, which is a managed firewall service built using next-generation firewall technology. You'll learn about how to apply granular security controls to inbound, outbound, and lateral traffic based on multiple use cases and design patterns to application and network workloads on OCI. My name is Renu Bhatt. I'm a program lead with the Customer Enablement team. Today, I'm joined by Katalin Andre and Bogdan Stoyan as our esteemed presenters. With that, I'll hand it over to Katalin.
Hi, everybody. In today's sessions, I will handle the introduction to the Oracle Cloud Network Firewall, and as a follow-up, my colleague Bogdan will take you to the deployment of this firewall and the use cases. Increasing cyber attacks are a critical issue affecting the organization, individuals, and societies worldwide. You as an IT professional, you witness this growth of these attacks that results in the data exploitation, holding the data ransom, or denials of service. According to a study, less than 50% of the enterprises are prepared to deal with such attacks, and 92% of the IT professionals believe that there is a readiness gap for these attacks. Imagine that you are working for an enterprise looking to host their online application in the Oracle Cloud infrastructure. As a security professional, you would like to limit the exposure of your workloads to the internet. In the public cloud, you're not physically controlling the entry points like the OCI gateways. The cloud native approach to the network security are the security list and network security groups are not designed to handle constantly evolving threats like exploits to vulnerability, spyware, and malware. You need a solution that can keep up with those threats. There are, of course, several marketplace images available to deploy a network appliance, but this implementation will introduce complexity for you, which includes the creation of the prerequisites for the network and security, like creating the initial configuration, handling the high availability, and not to mention maintaining the firewall policy. So if you want to automate the deployments of these configurations, you will need to use several tools from different vendors. The OCI Network Firewall is a cloud-native solution, and it's a managed solution, and we are managing from a single API endpoint, providing enhanced network protection for your workloads. So let's compare this to the cloud-native security list and network security groups. Now, if you are using the cloud-native, you're only allowing the whitelisting of the IP addresses. This network security firewall provides an action, like a drop or allow, and it has also a priority attached to the security. And also, let's not forget that it supports layer 7 network protection like URL filtering, SSL inspection, and intrusion detection and prevention. Although the session is focused on the OCI network firewall, layer defense is currently the best practice to secure your workloads. So both the network firewall and the web application firewall, which is also a cloud native solution, are considered like firewalls and network functions, and they are interacting with traffic, the network traffic at different endpoints. So giving the various potential points for intrusion across both the network and the web application. In most cases, it is important to employ both the technologies. So to sum up, the OCI network firewall is powered by the industry leader like Palo Alto. it is integrated with OCI, and this provides a service that is automated, and it automates the implementation and management of the firewall.
Good. Perfect. We will continue our discussion with the network firewall deployment, and after that, we will run some use cases, and probably these are one of the most encountered use cases for the network firewall infrastructure. But sure, there are some others, and where we can integrate the network firewall. But again, we picked the most used one in order to show you how easy it is to integrate actually the network firewall in the current design. So first thing first, let's go with the network firewall deployment. And I will start saying that we place the network firewall under the identity and security part on the OCI web user interface, where we can find the firewall step, right? Here, the web UI presents two options, the network firewalls and the network firewall policies, right? In order for us to define and actually create the network firewall, we will need a policy to be created upfront. So the first thing that we need to take into consideration is to create our very first network firewall policy. We will see that the network firewall policy, it's a combination of rules that we can create in order to achieve a certain scope, right? So first thing, we will need to go and create the network firewall policy. This is very, very important, right? And in order to create the network firewall policy, we will just go to the network firewall policy policies and create a network firewall policy, right? It will take a very short time to create the network firewall policy. And what you can see in the left side of the screen is the policy NFP. As you can see, the green color of the icon, it stays active, and actually it is ready for you to create what we are calling the security rules that will be applied to the network firewall and will enforce your policies to the traffic, right? Let's pause 1 second and discuss a little bit about what we can find in the left side of the screen under policy resources. So these are actually the features that are supported by the network firewall itself. And we have decryption rules, right, for SSL inspection. We have our security rules, but all our security rules are built by defining our application list, service list, URL list, right, address list, map secrets, decryption profiles, and so on. So there are certain functions, multiple options that are being supported by the network firewall policy. And here is the place where we can configure all of the security rules that we want to have in place. And as a side note, we will see later how we can configure actually the security rules to achieve a certain scope. Because in the use cases that we prepared, you will see very easy how the security rules are being configured. And after that, we will see also the logs, because the logging part of the network firewall, it's a very important component, and you can see in real time which action was performed on a certain traffic and which policy was applied. Now, after the policy is being created and associated with the network firewall, it can be, if you wish, modified. So we cannot modify the network firewall policy on the fly. What we can do is to clone the policy, as we can see here in this red squared button, clone policy. We will clone the policy. We will just create a copy of the working policy. No traffic will be impacted, right? And in this clone policy, you can perform any changes you want. You can add, remove, edit any entries that forms that network firewall policy. Then, after the clone part is ready, we can go and attach our brand new policy to the network firewall. And there are some very small use cases when some of the connections will be impacted. So once we are going with the policy update, if we update the mapping secret information, or this new clone policy or the new policy is using different mapped secret information than the old one, we might see a small downtime because the new mapping secret needs to be updated and used. No other issues will be seen if you are not using this mapping secret information, right? So only these two are the two use cases where some of the traffic might be impacted, right? No other issues. If these are not there, you will not see any other downtime in the traffic. So the network firewall policy with the clone policy creation, it will be very easy to be downloaded, modified, and applied back to the network firewall, right? So we have, as of now, we have our network firewall policy in place, and we will go to the next step actually and create the network firewall, right? The brand new network firewall policy should be in place, and after that, we will go and create the network firewall. Very easy. We will navigate to the network firewall and create a network firewall. Here in the left side of the screen, we will need some basic information. The network firewall will be configured with the policy that we have created. As you can see here, NFW-policy1. And now we have the enforcement point part. The enforcement point part will ask for the VCN where the network firewall will be deployed, the subnet, the availability domain, and here you have the possibility to manually assign a private IP address within the subnet where it is created to the network firewall. And we will see that this particular private IP address that it is gathered from the subnet where the network firewall is created is very important. And it is important because we will use this private IP address as a next hop in our routing entries. Because the network firewall is only acting as a bump in the wire. So we are placing the network firewall, we are directing the traffic through the network firewall by creating the appropriate route rules, and it will act just as a bump in the wire, right? After we have picked all this information from here, we have just we are using the button create the network firewall, and we will wait between 20-30 minutes for this process to complete. Why? Because the network firewall, the OCI network firewall, it's an OCI managed firewall. It is working in active state. As my colleague stated, it is powered by Palo Alto, and to create the entire infrastructure, it will take this 20 to 30 minutes for the process to be completed and for us to be able to get and to use the OCI network file. After this time passed, what we can see here, very, very simple. We have our network firewall, and what we can see is the IPv4 IP address that we specified before, right? The network firewall policy and the information regarding the VCN, subnet, and availability domain where it is created. Why is important the IPv4 address here? We will see that this is actually used in our route entries to direct the traffic to the network firewall and for the network firewall to be able to receive the traffic. And now, prior to go to our first use case, I can tell that it is very easy to include the network firewall in our existing networking topologies, because this will only require the correct routing to direct the traffic through this bump in the wire, right? And we will use the private IP address to specify it as the next hop in our route entries. Less words, more facts. Let's go to our first use case. And the first use case is presenting an existing networking topology, an existing production networking topology, where the OCI network firewall needs to be included in order to work in conjunction with the internet gateway and being able to monitor the incoming connections that are being received from the internet to the public IP addresses on the OCI VCN hosts. Let's go and see how this will look like. We have the internet with two hosts. This very simple networking architectures and structures looks simple, but contains most of the relevant details. Here we have two internet hosts, one starting with 150 and another one starting with 192, right? And I do have my virtual machine inside my VCN. And now the request is to insert the network firewall in between, and for 150 to allow the ICMP and SSH session to my 192.18.141.51 and deny the ICMP and SSH from 192, which is located here at the bottom in the right side of the screen. Right. And more than that, we need to configure the network firewall in such a way for all these actions to be logged. So I just want to see when my ICMP and SSH are being allowed from 150, and when my SSH and ICMPs are being dropped because the connections are being initiated from 192. Right. Let's go and see how we can configure this. First of all, first thing first, we will need to integrate the network firewall in between and configure the correct routing. So instead my traffic to go directly from the internet nodes at 150 and 192 through the internet gateway and from the internet gateway directly to my virtual machine, we will insert the network firewall in between. And the network firewall has an IP address ending with 20. So in which way we will configure this? In which way we will make the network firewall to act as a bump in the wire and to receive the traffic once it is received from the internet. First of all, at the subnet level where my VM sits, for example, I can have a default route, so all my traffic, no matter what the destination is, will have as next hop my network firewall. Very simple. At the subnet level where my network firewall sits, I will have a default route pointing to the internet gateway as my next hop, right? So the network firewall will send the traffic to the internet gateway. How about the returning traffic? Or how about once the traffic is being originated from the internet, how we can manage the traffic to flow through the network firewall? Once we have added the network firewall, we have included the possibility to attach a route table to the internet gateway and to the NAT gateway. We will discuss the NAT gateway a little bit later, right? This feature was not available prior to for the network firewall to exist. So in this case, we can create a brand new route table at the VCN level and attach that route table to the internet gateway. And what we will say in this route table, we will specify that my private subnet, where my VM1 sits, which is 192.168.0.0/28, will be reachable via my network firewall, 192.168.0.20. So once my internet gateway receives the traffic from the internet, no matter it is from 150 or 192, the traffic will not be sent directly from the internet gateway to my virtual machine. Instead, it will be sent to my network file for inspection. Right? We see how easy it is to define the routing. We see how easy it is to place the network firewall as a bump in the wire. Let's see how we will configure the network firewall to achieve the certain scope. And this scope is permit ICMP and SSH from 150 and deny ICMP and SSH from 192. More than that, this traffic needs to be logged, and I want to see the specific policy that was used for applying a certain behavior. Right. Let's go and see how we can do this. First of all, we will define some security rules. But in order to work with the security rules, I need to define some IP address list, right? And I will create actually 3 IP address lists. And I will place in my IP-address-list-permit, I will place my 150 host from where I should receive the traffic. I will place in my IP address list deny my 192 host because I don't want to receive the traffic from this one. And I will place my VCN nodes in the IP address list called IP address list VCN hosts, for example, where I'm matching my node. It can be the entire subnetwork. It can be a specific host. Here, I'm matching a specific host, right, with this /32. With this information, with this IP address lists that were created, I will go and create my security rules. And I will call this ICMP permit, SSH permit, and I will place this, I will put this just as a deny rule for any other traffic that needs to be denied. And it is very easy to be defined as I will work with my source IP address list permit, with my destination IP address list VCN hosts, application will be ICMP, and the action will be allowed. The same will be true with SSH. Instead, I will match the same source, same destination, application SSH, and allow the traffic. For the traffic that needs to be denied, I will place my source address being IP address list deny to my destination host here, IP address list VCN host, and I can use here with specific SSH or ICMP or any protocol, and the traffic will be dropped here. So I do have this 1, 2, 3 entries in my security rules. If I'm generating the traffic from 150 and from 192, let's see what the behavior is, right? Recall that we need to log this traffic. All the traffic needs to be logged. I do have my security in place. Let's see how this is looking, right? So for the allow logs, I can see that my action is allowed. I can see the destination. I can see the rule that was used to permit the traffic. And I can also see the source IP address of the traffic, which is 150, right? This is for ICMP. The same will be true for SSH, right? My action is allowed. The destination port is 22. The destination is the same, my VM within OCI. I do have my rule, SSH permit, and I do have this source, 150, 136. So most of the details that are necessary to track a particular connection, we can have it in that connection log, right? So the connection log or the session log contains all this information. Sure, the logs can be exported to any logging mechanism in order for us to have a centralized point to collect our logs. Let's see now how the denied traffic is looking, right? So we have the action drop for both ICMP and SSH. I can see the destination. I can see the protocol, ICMP, and I can see also my SSH connection on destination port 22. And here the rule is denied, right? So this rule was applied in order for this traffic to be dropped. And my source IP address is 192. So it was very easy to include the network firewall in the picture, create this particular security list to match certain nodes for specific traffic in order for us to have the desired type of connectivity in place, right? Very easy, very simple. Let's go to the next one, because this will use another gateway that is very, very used for different purposes. And we can also have the integration between the network firewall and the NAT gateway, right? And by using this, we will use a very important function that was implemented on the network firewall, and this is the URL filtering. So what is happening? Over the NAT gateway, only the VCN-initiated connections can flow. No one from the internet can initiate connections. But what is happening right now? The same VM will be able to initiate HTTPS traffic to production1test.com and production2test.com. But anything that it is related to production3test.com should be denied, right? So my VM is initiating sessions to 150, but it should be successful only to production 1 and 2 and not to 3. And for this, we will apply the same logic. We will create a routing first in order to place the network firewall as a pump in the wire with the NAT conjunction in place. And then we will configure for URL filtering, right? Let's see how we can, how actually we can do this. Right? First, we have a default route in the VM subnet pointing to the network firewall as the next hop. Now, for the network firewall, we will have the same default route, but we will switch from the internet gateway to the NAT gateway, right here. My next hop for this traffic will be the NAT gateway. And for the NAT gateway to be able to return the traffic back to VM1, we will have here the network firewall in the middle. So my route back to my subnet, back to my OCI subnet at 192.168.0/28 will be through the network firewall at 192.168.0.20. This is the single routing that we need to be in place for our network firewall to act as a pump in the wire, right? So here it is very simple, very clear. Let's see now how we will configure the network firewall to accomplish the scope for URL filtering, production 1 and 2 to be successful if the connection is initiated from my virtual machine 1 and to production 3 to be denied, right? Let's see it in action. First of all, we will define our application name, right? We will call it HTTPS, and it will have a TCP port of 443, right? Now, we will define the second step is to define our OCI network firewall URL list. And imagine that we have two URLs that needs to be successful, and the third one that needs to be, let's say, unsuccessful. Right? So we will place in the first URL list the blacklisted sites, and we will place our blacklisted URL production3.test.com, and whitelisted sites will be production1test.com and production2.test.com. So now we can go and create our security rules. We have our application defined. We have our URLs defined. Let's go and see how we will define the security lists. So the security rule for our traffic that needs to be permitted will look like in the following way. We will call it this HTTPS permit. And our action will be allow traffic. The source IP address will be the VCN host. Only from the VCN we can initiate the connection. The destination will be my 150 host, which is located on the internet. Sure, here we can use any if we have many internet destinations where we need to send this traffic. And here is the most important part. We are matching our HTTPS application and the URLs here, whitelisted sites. This contains production1 and production2.test.com, right? And the traffic will be allowed. For HTTPS denial, we will match the same IP address list VCN hosts to my internet destination for HTTPS, and the URL will be blacklisted sites, where the blacklisted is production3.test.com. And the action is normally drop. Perfect. We have our security rule in place, built by using specific source destination application and URL. And let's see, once we are originating the sessions from our VM to production1 and 2, how the logs looks like. Remember, this traffic needs to be allowed, right? So we have this allow and drop. The action allow here is depicted by the green part of the log. We have the destination port 443, we have the destination 150, we have the rule that was used, which is HTTPS permit, and my traffic is coming from 192.168.0.10, right? And the traffic is allowed. For the action drop, I do have the same destination. The rule used is HTTPS deny, and the source of the traffic is my virtual machine 1. So we can see that by using the URL filtering, we can accomplish certain scope, and most probably the URL filtering is one of the most requested functions together with the one that we saw previously. Right. So all of this can be logged. You can see which policy was applied for having a certain action, right? Good. Prior to go to resources, I can say that the network firewall can be included in sort of hub and spoke type of topologies. So it can be integrated with the dynamic routing gateway, with the DRG, or we can use the network firewall to inspect the east-west traffic or north-south traffic. If we are going to use hub and spoke type of topology with multiple VCNs associated with the same DRG, and if we are placing the OCI network firewall in the, for example, security VCN, we can do the routing in such a way for all the traffic that it is coming from on-premises to any of the VCNs to pass through the network firewall. The same is true if we want to monitor the traffic between our VCNs or between our VCNs and on-premises. All these parts are possible, and the integration is really easy. We will only need to create our policy to fulfill a certain scope and to create the correct routing. And when I'm saying the correct routing, this depends on the use case, right? So if we are going with hub and spoke, if we are using the internet, if we are using the NAT gateway, all of this can be accomplished by using the OCI network firewall. Now, under resources, we have our public documentation where we have up-to-date information regarding the OCI network firewall, the features supported, and how we can configure it. We have also a lab where we can, let's say, work with the OCI network firewall and integrate in certain scenarios. And there is an 18 Oracle Chronicles blogs where we pick a certain product, in our case, the OCI network firewall, and we are testing the network firewall by integrating in multiple most used networking scenarios. And these are based on real use cases, and where we actually show how we can configure it, how we can integrate it. We are tracing the traffic, and you can find a lot of useful resources we are waiting for your questions. Thank you very much.
Awesome. Thank you so much, Bogdan.
Sure.
If you could just take a look at the chat box. There were
Yeah, sure. Thank you very much, Cam. So for the first one, if we require both cases, private and public subnets in the same architecture, it is possible to use only one firewall. My understanding is because two different routes are needed, then you need two firewalls. Okay. Let me explain how this is working. So imagine that we have public and private subnets, right? If, for example, we are using both cases at the same time, the internet gateway and the NAT gateway, right? So for public subnets to go to use the internet gateway and the NAT gateway and the private subnets to use the NAT gateway, then yes, we will need to use two OCI network firewall. Why? It is not because of the network firewall itself, but because in the subnet where the network firewall is actually located, you cannot have two default routes pointing to two different next hops, right? So for this, we can actually manage to have a solution. For example, we can, to use just only one network firewall, we can use a default route pointing to the internet and to use some specific routes pointing to the NAT gateway, taking into account that mostly the NAT gateway is used, but it is not limited to this case. Is used for Linux updates, Windows updates, or something. So if we know the destination, we can have just only one network firewall and create more specific routes over the NAT gateway. But you are perfectly right. If we want to have both use cases tied together for private and public subnets with the internet gateway and NAT gateway used together, and if we need this default route, OCI does not permit to have two default routes in the same route table pointing to do two different next hops. So in this case, we need to segregate it. We will need two network firewalls, one serving, and this needs to be deployed in two different subnets, right? One serving the internet traffic or the internet gateway, if you wish, and the second one will be used for traffic flowing over the NAT gateway. So if two default routes are needed, then you will need to use two OCI network firewall in two different subnets to be able to configure the default route pointing either to internet gateway or to NAT gateway. Yes. We have OCI tenancy with fast connect and site-to-site VPN with on-prem and with EBS and Oracle DB workloads. However, security team requested for OCI network firewall deployment. Okay. Need to know, can we configure OCI with existing fast connect setup? And do we need to create separate private subnets for network firewall, or we can use existing private subnets? I have IGV and NAT gateway as well, along with on-prem connectivity. Please suggest how routes should be configured, network firewall and OCI VCN. Perfect. Yes, this case can be accomplished. You don't need to have another fast connect, so you can use this in conjunction with the network firewall. Here, you can place the best practice. The best practice is to define, for example, a brand new VCN, call it security VCN, where you will place the OCI network firewall. And you will create a sort of transit routing. So what this means that once your traffic from on-premises, it doesn't matter if it is for EBS or database, right? You will create a transit routing for this traffic to hit the DRG, and from the DRG, you will have, for example, at the virtual circuit attachment route table, you will have a default or routes pointing to your workload, but that will go through the network firewall. We are calling this transit routing. Then the network firewall will receive the traffic, will analyze it, will send it back to the DRG, and from the DRG will go directly to either to the EBS VMs, and more than that, the EBS will have a private load balancer. Then from the private load balancer, we'll go to the backend servers or to the DB. And this is perfectly valid, right? We can actually use that. And the same is true if you want to go with the traffic from your VCNs back to on-premise. we will to the on-premises. We will do the routing from your VCN to go first to the network firewall, and from the network firewall going to on-premises via the fast connect. Now, this is for the traffic accomplished from on-premises to OCI and vice versa. This is perfectly doable. Now, if you want to use the same network firewall for example, for NAT gateway or internet gateway, remember the following thing. The internet gateway is able to serve only instances that are within that VCN. So if we are placing the network firewall in another VCN, it will not be able to serve the traffic from your spokes VCN, where you have the EBS or where you have or where you have the database. What you can do, either you will change the topology and you will place the network firewall in a subnet from your existing VCN where your DB and EBS exists. And you will do the transit routing from on-premises directly through that VCN. That is not a problem. And the network firewall will be able to serve to internet gateway the hosts that are within that VCN. And the same is true for the NAT gateway. So you can use more specific routes over the NAT gateway and a default over the internet gateway. But if you want to have the default, then our previous discussion will take precedence. So you will need two network firewalls in order to accomplish this scope. Now, the best practice for the on-premises to OCI is to place the network firewall in a sort of security VCN and do the transit routing over the security VCN. Now, if you will need to expand the scope to internet gateway or to NAT gateway, normally, most of the VMs have private subnets, so only with NAT gateway will be just enough, right? But you can use the NAT gateway use case in that security VCN. You don't need to place the OCI network firewall in the same VCN. This restriction is only when you want to use the internet gateway, but not the NAT gateway. So all of this can be possible, but we need to see exactly what is your current architecture, and if it is the case to create another VCN to place the network firewall and call it security VCN, or we can place directly the network firewall within your existing VCN and do the transit routing over that. Both are valid cases. It will work, but we only need to see exactly which one is best for your security design, because most of the time we are working with the customer to fulfill their security, their security design. But long story short, both cases can be in place. Both will achieve this.
But Bogdan, if you would like to go back and see the follow-up questions on the answer you just provided, there are some questions in the chat box. And as usual, if you could just read them out loud so everybody else can also hear the questions, that would be awesome. Thank you.
Yep, sure. Okay, so this one from here, open. Okay, but how DRG talks with firewall and then VCN for both public and private subnets? Okay, so the DRG doesn't know nothing about public IP addresses that are being associated with the instances. So the DRG is able only to send the traffic to specific private destination. And for that, you will need to create a transit routing in a hub and spoke scenario. And I will give you just an example, right? So you are receiving the traffic from on-prem and you want this traffic to be sent first to the OCI network firewall. How we can achieve this, right? We will have some static routes in the VCN, in the virtual circuit attachment route table for all our spoke VCNs, for example, where you have the DB application and so on. And this static route will send this traffic to the VCN where the network firewall is. This is just the first leg. The second leg is to attach to the DRG what we are calling a VCN route table. And in this VCN route table, we can just create a default route pointing now more specific to the private IP address of the network firewall, right? This is the beauty of the solution. So we are forcing, once the traffic is reaching the DRG from the fast connect and has a destination any of our spoke, we will force directing this traffic to the VCN where my network firewall is. And then a second route table called VCN route table will actually direct to the private IP address of our network firewall, right? The network firewall in this way will receive the traffic to the private IP address because, again, the DRG knows only about the private IP addresses of our instances. The DRG doesn't know nothing about our VM's public IP addresses, right? Now, once the traffic is being received by the OCI network firewall, it is analyzed, right? It will apply the security policy that is configured for that particular traffic. And suppose that it is permitting the traffic. Then it will send the traffic out to the DRG. It will have, for example, specific routes for our spoke VCNs. It will hit the DRG and it will hit the VCN attachment route table associated with the VCN where the network firewall is, right? And in this route table, we have dynamically imported all our VCN prefixes. And in this case, the DRG will take this traffic and will send it directly to the VCN which has that particular destination. In this way, by using this transit routing, we can force somehow the traffic to go over our OCI network file. And the same is true for the reverse traffic. Once OCI responds, right, in the VCN attachment route table for our spoke VCN, we want all the traffic to go through the network firewall, right? We will have a default route specifying that the next hop attachment is the VCN where the network firewall is actually located, right? And then using that VCN route table associated with the DRG, we will direct it to the next hop IP address of the network firewall, right? The network firewall is receiving this traffic and will send it out back to the DRG. And in the route table, in the DRG attachment route table associated with the VCN where the network firewall is, we imported dynamically the on-premises routes learned over the fast connect. And in this way, we manage this. Now, the DRG cannot serve the public IP address of your instances. And it doesn't matter if your subnet is private or public. It will still get the communication to the private IP addresses of your private or public subnets. The difference comes when you have public subnets and VMs with public IP address associated, and you want to go to the internet, or you want to receive the connections from the internet directly from the internet over the internet gateway, right? Or if you have private and if you want to go to the NAT gateway, but the DRG itself doesn't know nothing again about the public IP address which are associated with one of your VM. For the DRG, it doesn't matter if that subnet is public or private. It will only know about the private IP addresses of your instances. That's all, right? Yeah, these are actually very, very, very good questions. And again, all these use cases are possible because it is not only about the network firewall. You can replace the OCI network firewall with any other, let's say, virtual machine that will expose a private IP, and you can do the routing for that machine to receive the traffic. But OCI has this capability, and the OCI network firewall can be integrated very easily in this particular picture. And all the use cases that we have discussed are valid use cases.
Fantastic. So I think we're done with the questions. As Bogdan mentioned, let me just iterate something really important here. We have plenty of documents online, all for education. You have blogging platforms, a lot of different scenarios. The difference between an official documentation and a blogging platform is a blogging platform is primarily focused on different scenarios and use cases. You have that. You also have access to live labs. If you Google those, you can also find the live labs we created for different technologies. In addition to all this, you have official Oracle documentation. Oracle University has a lot of different resources that you can use for not just network firewalls, but also all CI technologies. And on top of all this, as an Oracle customer, you will have access to your account team, and you can engage the exact same team, same presenters you're talking today. If you have questions, you want to have a whiteboard session with them, you want to have a follow-up workshop with them, any other training sessions, all possible. Just get a hold of your account team if you're an Oracle.
Thank you, Bogdan and Kathleen, for a great session. And Bogdan, especially for those questions you answered at the end, that was like an icing on the cake. Our next session will be on Monday, May 20th, where we'll cover OCI approach to multi-cloud. You'll be introduced to a private connectivity strategy to interconnect many cloud providers to Oracle Cloud infrastructure. You'll also see a live demo focusing on establishing a multi-cloud connection in that session. If you're interested, please do not forget to register for the session. I recommend that you bookmark the Devon and Beyond page and check frequently for new sessions on trending topics. With that, thank you again for joining us. See you all next time. Have a great day, everyone.
Thank you. Bye-bye.
Thank you.
Cool.